I'm August, Oakland Senior 2020, and today I'm going to explain to you how to cut aluminum, this shiny, ultra lightweight metal on the plasma table. This is a little different than a ferrous iron steel because you cannot use the ohmic cap sensing to detect the height. You have to manually program that in. So let's begin. First, this is the only aluminum I have, so I'm going to set this up here just to show you what we're doing. You're going to go over to that chart as I explained in the last setup video and follow the numbers. Things are a little bit different, so make sure to pay attention to that. And again, inches per minute, knock it down about 10%. It says to run it at 106. I would run it at 95 for this. Now, once you get to this section of it, this is where things get a little bit weird. So usually you can just run your job setup, plug in these numbers, your inches per minute, and click OK and go. Now the difference is that with aluminum, you can't use this setting right here, your ohmic sensing setting. What this does is following this wire, sending the connection through here, through the ohmic cap, and when it touches the metal, it's going to go through the ground clamp and recognize that it is making connection. This is the top of the metal, this is where it touches. For some reason with aluminum, it doesn't do that even though aluminum is conductive. So you have to manually program that in. Usually this is going to be on. You're going to click that and turn it off. Over here, you're going to have to set up your material thickness. Just pretend we're just cutting with the usual 1/4 inch aluminum. That's the most common that you're going to find. So I just put in a number here for demonstration purposes. So we're cutting with 1/4 inch aluminum. You are going to bring the torch down until it just barely touches that metal. It's a little too far. And you want to be pretty tedious with how close this is. Now, if you can see that, the torch is touching the metal, but not putting much pressure on it. It's just enough for you to not be able to slide a piece of paper under it. That's what you're looking for. Once we have that there, we're going to come back to this, and we're going to click Set for the top of the material. This is going to allow the torch to recognize the height of the material. You go through your settings, knock it all in. Again, recommended settings 106. I'm going to put it as 95. Okay. Also, don't do what I just did where you click and it messes this up. 95. All right. You go through, set your program 0, blah, blah, blah. One thing I forgot to mention. It's good to make sure that your Z position and your servos are not misaligned. So before you do this, click your reset Z position, and it's going to re-zero all of your servos. Luckily, I just did that a minute ago, so you're not going to have the issue, but it should usually pop up with a thing, limit exceeded in Z or Z position error, blah, blah. Just click OK, it fixes itself. No harm, no foul. After you go through the settings, you turned off the ohmic cap settings, you have set the height, you've set the height of material thickness. Now you can run this just like a normal program. You can just click Run Job, do whatever other settings you need to, set your program 0, blah, blah, blah. My recommendation is to always run this as a dry run before you run it as an active run. Now the difference between these two, active run means that it's actually blasting out and cutting the metal. A dry run means the torch is just going around the path and not actually cutting. I would recommend doing that so that you don't waste the material if there's an error, and 2, you want to make sure that the height you have set for everything is actually going to work across the board. You don't want it to get too close or get too far away if the material isn't level. That's why aluminum is kind of a pain on this thing. But yeah, run it as a dry run first, let it run through, then you can select active run and rerun the program. And that is how you cut aluminum on the Lincoln Electric plasma table.